Hey everyone, take a moment and just feel the ground beneath you. It feels solid, right? Unmoving, like the earth is just a big, quiet rock. But what if I told you that underneath that calm surface, the heart of our planet is raging? That the earth breathes, sleeps, and occasionally it screams? Just recently, we heard one of those screams. It happened in Ethiopia, and it wasn't just a loud event. It was an ancient one. The Hayli Gubbi volcano erupted. Now, get this. This mountain had been sleeping for nearly 12,000 long years. Think about that time scale. The last time this volcano spoke, the Great Ice Age was just wrapping up. It had no known Holocene eruptions until now, according to scientists like volcanologist Simon Kahn. Isn't that simply astonishing? When it finally woke up, it didn't just puff a little smoke. It sent a massive, thick plume of ash, a terrifying mix of gas and pulverized rock, nearly 14 kilometers, 9 miles, into the sky. And here is the interesting fact. That ash cloud didn't respect borders. It didn't stay contained to the Afar region where the volcano sits. It drifted right across the Red Sea towards Yemen and Oman. It was such a massive event that the ash eventually reached countries as far as India, showing up over the state of Rajasthan and also northern Pakistan. Did you realize that a sleeping mountain in Africa could instantly disrupt air traffic thousands of miles away? Global authorities, including the DGCA, had to issue an urgent advisory. Carriers like Indigo and Casa Air KM had to cancel or divert flights because that ash is seriously dangerous to jet engines. The Earth reminded everyone, very loudly, that it's all one interconnected system. So, how does a quiet mountain, silent for millennia, suddenly find the colossal energy to explode? Let's go deep underground to find the answer. To understand an eruption, we have to look past the dirt and rock. We need to look at the Earth's layers. Deep down, it's incredibly hot, hot enough that some rocks actually start to melt slowly. This molten material is what we call magma. Since this magma is lighter than the solid rock surrounding it, it naturally starts to float upward. Think of it like a giant hot air balloon trying to reach the surface. This rising magma pools beneath the surface in big underground rooms we call magma chambers. This is the volcano's fuel tank, sitting and waiting. Now look at the Earth's crust itself. It's not one smooth shell. It's broken up into huge pieces, the tectonic plates. These plates are always moving, slowly, maybe about the speed your fingernails grow. Volcanoes usually pop up where these giant puzzle pieces interact. They either crash into each other or, in the case of Ethiopia, they pull apart. The Hayli Gubbi volcano is right in the Afar region, part of the East African Rift Valley. This is a spot where 3 tectonic plates are slowly, relentlessly splitting the Earth open. That continuous stretching creates deep fissures, cracks in the crust. These cracks are perfect escape routes for the magma below. The location helps, but the real secret to a volcano's power isn't the rock, it's the gas. Imagine you grab a can of soda and shake it up really well. What happens? The liquid holds dissolved carbon dioxide, CO2. The moment you open the can, the pressure drops and those gases violently explode out. Volcanoes operate exactly like that, but with superheated rock instead of soda. Magma is loaded with dissolved volatile gases like water vapor and sulfur compounds. As the magma rises toward the surface, the overwhelming weight of the rock above it, what scientists call lithostatic pressure, decreases. When that pressure drops, those gases bubble out, creating millions of tiny high-pressure gas bubbles. These bubbles make the magma lighter and increase the buoyant force pushing it up. Now, the style of eruption depends entirely on the thickness of the magma. If the magma is thin and runny, the gases can escape easily, maybe constantly. This gives you those beautiful, relatively effusive eruptions you see in Hawaii. They produce slow-moving lava flows. The good news? Lava flows rarely kill people because they move slowly enough for folks to get out of the way. But if the magma is thick and sticky, the gases get trapped, building up immense explosive pressure. When that pressure finally overcomes the strength of the overlying rock, everything explodes violently. This kind of explosion blasts the magma into the air, where it shatters into pieces called taphra. Taphra can be anything from powdery ash, the stuff that grounded those plains over India, to giant boulders the size of a house. The eruption of Mount St. Helens in Washington is a classic example of this explosive gas-driven power. Let's return to Ethiopia and the incredible scene of 2025. As volcanologist Simon Karn pointed out, Hayli Gubbi had no known Holocene eruptions. It was dormant, not extinct. Scientists knew that magma movement was happening deep underground in the Afar region. The tectonic plates constantly pulling apart meant the crust was already stretched thin. Eventually, that internal pressure, that giant soda bottle building up gas for centuries, was just too much for the thin crust to handle. A local resident named Ahmed Abdallah described the sheer shock of the event. He said he heard a loud sound and felt what he called a shock wave, explaining it felt like a sudden bomb had been thrown with smoke and ash. Can you even imagine that sound? That feeling? The eruption sent ash 14 kilometers into the atmosphere. What makes that ash so dangerous to us globally? It's not soft dust, it's tiny, sharp pieces of rock. When those particles enter a jet engine, they can cause severe engine or cabin anomalies. That's why the DGCA order was so important. They told airlines to strictly avoid all ash-affected routes and altitudes. Passenger safety, they stated, remained the absolute top priority. And on the ground, the consequences hit hard. Local official Mohammed Said noted that while they hadn't lost human or livestock lives so far, the ash covered many villages. Think about the local livestock herders. Their animals suddenly have little to eat because the pulverized rock has suffocated the plants. This single eruption wasn't just a powerful moment for geology. It was a profound human crisis. Delayere threats, hazards that move faster than any human can run. The most terrifying hazard is the pyroclastic flow. This is a catastrophic, chaotic mixture of super-hot rock fragments, ash, and gas. We're talking about a cloud that is typically hotter than 800 degrees Celsius, over 1,500 degrees Fahrenheit. It races down the mountainside at speeds of hundreds of miles per hour. Pyroclastic flows are incredibly destructive because of their extreme temperature and mobility, capable of destroying nearly everything in their path. Then there are lahars, the volcanic mud flows. This happens when hot volcanic materials mix with streams, heavy rain, or suddenly melted snow and ice. This mixture becomes a fast-moving slurry, often compared to wet concrete. Historically, lahars have buried entire communities located near erupting volcanoes. It reminds us that hazards like lahars and debris avalanches can strike even when a volcano isn't actively erupting. But there's one more layer of global impact: climate. Volcanoes can definitely affect our weather and climate. Think back to the 1991 eruption of Mount Pinatubo in the Philippines. That explosion blasted fine ash and gases high into the stratosphere. The result? Cooler than normal temperatures were recorded across the whole world, and we saw brilliant, colorful sunsets because of that drifting volcanic cloud. It shows us how big this system truly is. We live on a living, breathing planet. The eruption of Hayli Gubbi, dormant for 12,000 years before its sudden, shocking awakening, proves that ancient geological forces are still at play every single day. The Earth is a work in progress. But here is a beautiful truth we shouldn't forget. Volcanoes are not just destroyers. they are also powerful architects of life. Over vast stretches of time, those volcanic materials, the same stuff that threatens airplanes and herds, eventually break down and form some of the most fertile soils on Earth. This has literally fostered civilization, allowing us to grow abundant food. Plus, the intense internal heat from young volcanic systems is a clean source for geothermal energy. The next time you see footage of a volcano, remember the whole story. Remember the sheer terror of the shock wave, the global reach of the ash, and the incredible, persistent power of magma rising from the core. The Earth is alive, constantly moving, and always changing, and we are privileged witnesses to its powerful, ongoing creation. If you found this explanation of Earth's fiery engine room fascinating, please hit that like button and tell me in the comments, which powerful natural force should we dive into next?